Hi everybody and welcome to, seriously, what is going on? Welcome to part 2 of exponent laws and radicals. So today we're going to take a look at some more laws, reviewing multiplying and dividing, and in the challenge section we're going to be taking a look at fractional exponents. It's going to be a barn burner. Here we go. Welcome to part 2 of exponent laws. Let's get at it, shall we? This is the sequel. Hopefully you guys saw the original. You know, when you think about what are the really good sequels that are better, a lot of people say Godfather Part 2 was better than Godfather. You know, Episode 5 was better than Episode 4. The one that doesn't really work was Indiana Jones, Temple of Doom. It was horrible. That was a horrible sequel. Terminator 2, T2 was much better than the first Terminator. You might not have seen Terminator. That's that Arnold Schwarzenegger guy. When he did, I'll be back. He did that kind of stuff. Yeah, you should go check it out if you haven't seen it. There's 2 more laws we need to go. And we're going to say x to the, how should I say this? X to the negative y. So we're talking about negative exponents right now. So this is where we're going to say it's 1 over x to the positive y. Now, this always causes so many problems. So I'm going to show you an example right off the bat, because if you look at this, a lot of kids just think you flip it. You flip it and you get that. And I totally understand why. So I'm going to give you an example. And this is the actual law, but my example will make it seem will make sense. So I'm going to say 2x to the negative 3 over 5. Okay. So that's what I'm going to do. Now, this is how I want you guys thinking about this, is when you have a negative exponent, you're not allowed to, first off. It breaks all the math rules. The universe blows up. It's bad. It's like infinity stones. Just bad things happen when you have them. So negative exponents aren't allowed. And how you change a negative exponent to a positive exponent is by moving it up or down in the fraction. That's how you do it. So if you take a look at this one right here, you have x to the negative 3. You say, that's bad. Bad things happen. I need to move that down. So I need to move this down. Notice nothing happens with my 2/5. Absolutely nothing. So that leaves me with 2 over 5x to the positive 3. Okay, so that's all that happened. That just moved down. So when you look at this, and this is how textbooks show you, and they show you this way, and this is how teachers typically show you, a lot of kids think you're flipping. So a lot of kids think over here is that the 5 and the 2 flip. Because what teachers sometimes fail to show you is that this is 1x to the negative y over 1. And maybe I'll even just kind of, because the fractions are all over 1. So if I kind of put that 1 there. So what is really happening is this x to the negative y is moving down. Because a lot of kids ask, where did this 1 come from? Where did it come from? Well, it was right there the whole time. Nothing was changed. So it's not flipping. It is not flipping. This is a no flipping zone. No flipping, okay? There we go. So think of this example and think of moving up or down. And the other law, the last law that I need to introduce you to is, I love this law, x to the power of 0. Oh, something to the power of 0 is 0. No, it's not. It is not. You think it would be. It's actually 1. What? Something to the power of 0 is 1? How could that possibly be? All right, let's go and prove it, shall we? Okay. Let's think of the number 1,000. And if I had to make this into a base 10, 10 to the what gives me 1,000? Well, hopefully you might know that 10 to the 3rd. Okay. Let's go to 100. So that would be 10 to the 2nd. Okay. How about 10? Are you seeing a pattern? 10 to the 1st. How about 1? Follow the pattern, everybody. It's 10 to the 0. Okay. So this kind of goes and proves that anything to the power of 0 is 1. Anything. I'll tell you, once upon a time, there was a math teacher. He might have been named Mr. Douglas. And he gave kids this question on a test. And it was an awesome question. It was in the exponents section. And when he was making this question up, he thought it was amazing because, you know, it was really, it might have been even more complicated than this. Like, we're talking, like, it was crazy. Minus 2z. Whew. And you see hopefully where this is going, all to the power of 0. So hopefully you know this, that the answer was 1. But on that fateful day, as I was walking around to seeing how the test was going, I saw one little student, and they were trying to work it out. They were doing all of this math. You should have saw their paper. It was crazy. And I went over to their desk, and I just saw that, and I just circled this. And then the child looked at me, I think fairly angrily, and he did that. And I laughed. He did not. But it does serve a purpose of just look at the question, breathe, and always just think of, what's the best way to solve this question? So, word to the wise. If you see something like this to the power of 0, the answer is just 1. Easy peasy. So, shall we get to some examples now, shall we? And the examples will be very helpful for everybody to solidify some of these ideas. So, here we go. An example. And let's just start with this. 7x to the negative 3 over 8. Y to the negative 2, like that. Okay, so you're seeing this one, and you're thinking, I can't have negative exponents. So that means these ones have to go down, doop, and these ones need to go up. So your final answer is 7y squared over 8x to the third. Okay, well, that's not too bad. Let's see something else. What happens when you have the same variable? I always use this as big exponents. Now, there's a couple different ways to look at this. Oh, I don't want that. I'm going to change that to 3. Let's make it different, because otherwise that would not get the point across that I want to get across. Let's make it a 7. Okay. So let's say you saw this question. What this really means, if I wanted to go and write this out, this means 3x, x, 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 4, 5, 6, 7, 8, 9, 10. So that's 3 to the 10ths over 7, and there's 12 of these. 1, 2, 3, 4, 5, that's a bad one, 6, 7, 8, 9, 10, 11, and 12. Okay. Whew. Now, this is what I want you to ask yourself. Okay, this is what I want you to ask yourself. So you're a little kid, and okay, there's Sally, and Sally's thinking, I want to think, which has more x's, the top or the bottom? And Sally thinks it's the bottom. That's where your x's are going to go. Okay, so Sally's like, okay, there's more x's on the bottom, that's where they have to go. Great. Now think, when you divide exponents, when you're dividing, what are you actually doing? You are subtracting. Do you remember that from the very first lesson? So I'm subtracting. So what's 12 minus 10? 2. Great. And where do they go? On the bottom. So my final answer is going to be 3 over 7x squared. Now visually, if you want to do it, I would eliminate these 10 x's, and I would eliminate these 10 x's, and these 2 x's would still remain there. So that's why they're down there, because there's more of them. So think about that. Where is there more? Do your subtracting and leave them there. Let's kick it up a notch. So let's say we had 5x to the negative 3, y to the negative 5, z to the 7th, all over 8, x to the 7th, y to the negative 2nd, z to the 4th. Okay, so remember Sally. Sally's always happy, and she's just thinking, where is there more? So when she's thinking about her answer, she's like, boom, boom, boom. Okay, we're going to have some fractions. It's going to be 5 over 8. You would simplify that if you could, by the way. If you could, but you can't simplify 5 over 8. So let's deal with our x's right now. So let's go and deal with our x's. So we're just going to deal with these ones. What number is bigger, -3 or 7? 7. So their x's are going to go down here. I already know they're going to go down here. And now I have to subtract. Be careful. I have to subtract. What am I subtracting? -3. So 7 minus -3 is actually 10. So x to the 10th. All right, let's go with our y's now. See with our y's. What number is bigger? This is tricky. -5 or -2? -2 is bigger. So I know my y's are going to go down here. And I have to go and subtract. What's -2 minus -5? That's going to be 3. And finally, I'm going to go and deal with my z's. Which one's bigger? 7. So my z's are going to go up here. I already know that. And what's 7 minus 4? Also 3. And that, ladies and gentlemen, is what Sally would answer. Good job, Sally. Excellent job. And that's probably one of the more challenging ones that you're going to see. But there's a few more that always are a little bit tricky that we're going to go over right now. And they're not that bad. That's what the math teachers always say, don't they? It's not that bad. Don't worry. Okay, so these ones involve brackets. We'll start out nice and easy, and I'll show you some different ways that you can look at this. If you have 3/5 to the power of -1, and the -1 is like an outside brackets, remember our rule is that the exponent would apply to the numerator and the denominator. So this would really be 3 to the -1 over 5 to the -1 like that. Now, you have the exact same rule, so you can't have negative exponents. So the 3 would have to go down, and the 5 would have to go up. So this would end up being 5 over 3. Now, there are different ways that you can kind of look at that. Some people like to talk about if you have something to the power of a negative exponent, you simply flip it, and you change the sign of the exponent. So what I mean by that is, let's say we had same sort of idea. Like, let's just say we had, I don't know, 7 over 8 to the power of -2. Well, some people say you just flip it, 8/7, and you make the -2 become +2. And then you apply the square to 8 squared over 7 squared. So you get, I guess what, 64 over 49? Same kind of idea. Different ways to kind of think about those ones. And those are neat little ones to kind of be thinking about. Let's just kind of stay on with the negative exponents. And let's say you had something that was like 3 to the power of -4 squared. Well, you want to follow your exponent laws. So this is 3 to the power of -8. You have to go and multiply those together, don't you? That's what our original laws said. But 3 to the power of -8 is, and I'm going to put this 3 is over 1. So don't forget that. And also, this is kind of tricky, but if I times this by 1, so this is like 1 times 3 to the -8. So I'm just going to be moving, this down, okay? That's what I'm doing. I'm just moving that down. So that 1 is still there. And that's going to leave me with 1 over 3 to the power of 8. And I'm not going to do 3 to the power of 8 because that's crazy. Okay, so that's pretty important. That's a good tricky one to kind of be looking at. And what else could we kind of be doing here? I think that kind of wraps it up. You can take a look at some of the different rules, but that should give you a good idea with negative exponents and also to the power of 0. Hope you enjoyed.
So as we mentioned, in this challenge section, we're going to be taking a look at exponents that are actually fractions. And It will be very, very interesting to see how it all works. Let's get to it.
Fractions and exponents. Yes, that's what we are going to be looking at. Let's just jump right into it, shall we? Let's say you have x to the power of y over z. Fear not, students. All you have to remember is where everything goes. So, first things first, where does the x go? Where does the base go? It goes inside. And the z becomes the index, and the y becomes the exponent to the base. That is not too bad to think about. How did I remember that when I was a kid? Well, this is how I kind of looked at it. Like, it's x to the yz. So the y's on top. So the y is just going to remain the exponent. So it's just going to be kind of like x to the y. And then, well, that just leaves me with z. So z, has to go on the outside. And z is really cool to say. So z becomes the index and tells you what you're doing. Let's go and take a look at some of the most famous things that would look scary, but it's really not. You've been doing them for years and years and years. 16 to the power of a half. Now, if you saw that, you'd be freaked out. But in reality, what that really is 16 goes inside. The 1 goes here, so that's easy. And this becomes right here. So we're just asking you, what's the square root of 16? 4. That's it. 16 to a half. Looks scary. It's really not. Let's take a look at another really famous one. 8 to the power of a third. What? So that would freak out a lot of kids who didn't watch this video, but now that you have, the 8 goes inside. It's to the power of 1, so that's just 8. And it goes right here. What's the cube root of 8? Well, that's just 2. So you've been doing this the whole time. You didn't even know it. Crazy. But there is a little catch. So let's take a look at the little catch. This is going to make your life so much easier. And we're going to use an example to show this one. So 27 to the power of 2/3. Okay, so you're like, Right away, you know that this is going to be a cube root. You know that. So we'll use green. And I'll put the 27 in here. And this is now a cube root. And the square goes there. Does anybody know? Raise your hand. What's the square of 27? I have no idea. Nor do I want to go and figure that out. But we can actually go and rewrite this in a much cooler way. So watch this and be prepared to be blown away. We can rewrite this as this. It's still a cube root. We're still 27. But we're going to put the square outside here. Whew. Let's follow order operations and do stuff inside the brackets. If I do the stuff inside the brackets, what's the cube root of 27? Well, that's easy. That's 3. And what's 3 squared? The answer is 9. There we go. There we go. Hair. That was fun. Give some arms, leg. Okay, so it's 9. There you go. That's pretty cool, right? So you can put like the numerator on the outside of brackets and just keep this as your index if that's going to help you out. So let's take a look at a few more of those ones because, honestly, what are teachers going to give you on tests? They're going to give you that one because that one really does show if you are understanding some exponent laws. So let's even try and trick you a little bit more and put 16 to the power of 1.5. Now, if you're looking at that, you're going like 1.5, well, what am I going to do? Because, again, your teacher's probably taking away your calculator. Remember, this is really 16 to the 3 over 2. Hopefully you remember that 1.5 is actually 3 over 2. So you're like, okay, I got this. No problem. Well, again, 16 would go inside. It's a square root. And normally, you would go and put the 3 right here, right? But do you want to do 16 to the power of 3? Heck no. I don't want to do that one. So what I'm going to do is I'm going to put it in brackets and put it to the power of 3. Well, what's the square root of 16? Easy peasy. That's going to be 4. And what is 4 to the power of 3? I think that's 64. That's way easier than doing 16 to the power of 3. So there you go. That's not too bad. So that's a really cool trick. Should we see one more? I think we should see one more. What would be another good one? Oh, okay. This isn't a good one yet. I'll give you a few more. But this is just a reminder, really. So say you had 25 over 36 to the power of a half. Okay, so you kind of know that, a reminder that this is going against both of those. Whenever you see something to the power of a half, they're asking for the square root. So that's something to kind of get used to. So this is like the square root of 25 over the square root of 36. So you're just looking at a 5 over 6. So just a quick little reminder. Those halves, those are things that you really want to be kind of memorizing and just knowing from that. Let's get on to the really cool questions. But Mr. Douglas, all questions are cool. That is true, student. That is true. All questions are pretty cool. But some are just more cool. All right, if we had x minus 5 to the power of 1/5 equals -2. I wouldn't really know where to start. Because we can't just go and do x to the 1/5 minus 5 to the 1/5. We just can't start doing that. That's not going to work. So you got to be thinking, how could I get rid of the 1/5? Pause the video. Take some time to think. Go for a walk. Go play with your puppy. If you have a cat, go get a dog. So how would you get rid of that 1/5? Well, the golden rule, remember the golden rule says we can do anything to an equation as long as you do it to both sides. So I want to get rid of this 1/5. So I would start thinking about reciprocals. Well, could you go and do this? I'm going to put this whole thing to the power of 5. And that means I need to do it to this side as well. Now, why do I want to go and do that? Well, according to exponent laws, I need to go and multiply this. And 5 times a fifth is simply 1. Oh my gosh. Anything to the first power is just itself. So this question now becomes x minus 5 equals -2 to the fifth. Now I can do that -2 times -2 times -2 times -2 times -2. I can do that. That's not bad. That's just going to be -32. Just like that. And that isn't too bad. Now I'm going to go and add 5 to both sides. Add 5. And I have x equals negative. Whoop. So x equals -27. That is cool. Shall we look at that one more time? Or are you good with that? I think you'd be good with that. So there's the trick. Multiplying your exponents by the reciprocal and doing it to both sides to make your life a little bit easier. So there you go. You got some fractional exponents going on. And if you watched last lesson and you've taken some really good notes, you should be tackling exponents with confidence. Good luck.
Thanks everybody for tuning in to all of this information on radicals and exponents. Take a look at some past videos if you want to also brush up on exponent laws, and hope you enjoyed everything and took something away. Until next time.